Okay, today we're going to be looking at section 4.7, which deals with arithmetic sequences. First statement would be I can identify and extend patterns in sequences. I can represent sequences using explicit and recursive formulas. I can represent sequences using function notation. So if we read this first scenario here, we can kind of get an idea of what sequences are. So it says a wooden post and rail fence with 2 rails is made as shown below. Find the number of pieces of wood needed to build a 4-section fence, a 5-section fence, a 6-section fence. Suppose you want to build the fence with 3 rails. How many pieces of wood are needed for each fence? Describe the pattern. So let's just first look at this first basic scenario that they got. So if we have 2 posts and 2 rails, that's going to be 4 pieces. The next one for 2 sections would be 7 pieces, and the next one with 3 sections would be 4 pieces. So we can see that the pattern here is that we're increasing by 3 pieces each time. So our sequence would be written as such: a 4, a 7, a 10. Obviously the next one would be 13, and then we use dot, dot, dot to say that we continue. Okay, so sequences are simply an ordered list of numbers that represent, or that often form a pattern. Doesn't have to form a pattern, but oftentimes do. Each number is called a term. So specifically today we're going to be looking at arithmetic or arithmetic sequences. The difference between the consecutive terms in an arithmetic sequence is constant. That's how you identify an arithmetic from a non-arithmetic. Would be the difference between the two is constant. So this difference is known as the common difference. Okay, so let's take a look at a few things. So first of all, describe the pattern of each sequence, then find the next 2 terms. So one of the things you'll have to do today is try and find the pattern. So if we look at this first one, it goes 15, 11, 7, 4, 7, 3, negative 1. So we can see that the pattern is decreasing by 4 each time. So that would be the pattern. We'd say the pattern is we just decrease by 4 each time the first term is 15. So that's how we describe it in words. Then to find the next 2 terms, we'd say the next 2 terms would be a negative 5 and a negative 9. So again, in words to describe the pattern, each term decreases by 4. First term is 15. If you chose to say the first term is 15 and then each term after that decreases by 4, that would be fine as well. Okay, so we look at the next one. The next one we got a negative 2, a 2, a 6, a 10, a 4. Just so happens that this time we are increasing by 4. So we could say that, first of all, to describe the pattern, we could say first term, so I'll write it the other way this time. First term is negative 2 and increases by 4 after that. Okay, so something like that would describe it. If we want to find our next 2 terms, if we add 4 on the 14, we get an 18. If we add 4 on the 18, we get a 22. So those would be our next 2 terms. Okay, so same thing here. We go a 1.5, a 3, a 4.5, a 6. So you do those next 2 here, and you can, we'll pause it, and you can see if you got it right. Okay, so the first one, you should have saw that the pattern was increasing by 1.5 each time. So our next 2 terms would be a 7.5 and a 9. If you were asked to describe it, you should have said something like the first term is 1.5. After that, we increase by 1.5 each term. So that would have been what you should have had in words. This next one, we go 6.8, 5.4, 4, 2.6. So we can see that here we are decreasing by 1.4 each time. So if I decrease by 1.4 here, I would get a 1.2. If I decrease by 1.4 again, I'd get a negative 0.2. So in words, you would have said something like the first term is 6.8. Each term after that decreases by a 1.4. Okay. Another thing you will be asked to do today, tell whether a sequence is arithmetic. If it is, identify the common difference. So first of all, what does it mean to be arithmetic again? That simply means that the common difference between, or excuse me, the difference between the two terms is always constant. So if we take a look at the first one, here we increase by 6, we increase by 6, we increase by 6. So this one is arithmetic. So we write arithmetic. And the common difference we obviously said was positive 6. So if you look at this next one, we go a negative 14, a negative 10, a negative 7, a negative 3. So the first time we increase by 4, then we increase by 3, then we increase by 4. So is this one arithmetic? We would say no, not arithmetic. It does not have a common difference, so it's not arithmetic. Okay. You take a look at these two, see if you can figure out these two. So the first one, we go up 15, we go up 15, we go up 15. So this one is arithmetic. And our common difference is 15. Next one, we go up 4, and then we go up 2, and then we go up 2. So is this one arithmetic? The answer here would be no, not arithmetic. So again, we have to have that common difference each time. Okay, last thing that we're going to talk about today is recursive formulas. So if we are given the sequence of 7, 10, 13, 16, some things we can look at. So we could say symbolically that the first term is 7. So this here just simply says the first term is 7. Second term is 10, which is simply the first term plus 3. The third term is 13, which is simply the second term plus 3. Fourth term is 16, which is the third term plus 3. So we could say we could find any term, or to find any term, you can take the previous term and add 3. So what does that look like symbolically? So symbolically, we could say to find any term. This symbolically simply represents the previous term. So the previous term is an n minus 1. So any term, to find any term right here, you can take the previous term and add 3. So the recursive formula for the sequence would be as follows. We would say to find any term of the sequence, you take the previous term plus 3, and you have to give that the first term is 7. So how could we do that for some other sequences here? So to write the recursive formula, again, it's always going to look like this. A-N. Let me try that again so it looks a little clearer. Is equal to the previous term. This is always going to be in there. And what are we doing with the previous term? In this case, we are subtracting a 4. Okay, and then we always have to give that first term. The first term is 16. Okay, you could write it the other way as well. You could say that, in this case, you could say that the first term is negative 8, and then any term after that is equal to the previous term. And let's see what the pattern here is. We increase by 2, increase by 2, increase by 2. So it would be the previous term plus 2. Okay? So hopefully that makes sense to us. If not, we should be coming with some questions tomorrow. And that is a wrap.